Hello friends, I am Vikram, studying in Sri Chaitanya Engineering College, Karimnagar. Now today we are going to study about analog to digital converters. In that we are specially going to study about RAM tap digital converters. Analog to digital converter circuit is a circuit which converts analog signal into digital signal. But here it is called RAM tap digital converter because in this circuit it uses a ramp generator to produce the signal. This is the block diagram of the ramp tap analog to digital converter. This is called ramp tap converter because we have in this circuit we have used the ramp generator in the circuit. So this total system we call as the ramp tap analog to digital converter. The main building blocks of this circuit are the comparator, ramp generator, control logic, latches and display unit. In this total circuit, the control logic is the brain of this ramp tap analog to digital converter. Mainly this control logic controls the latches, counter, ramp generator, comparator, etc. Now here the output of the ramp generator is in linear nature. It is represented with VR. Here the comparator is given by the two inputs. One is the analog input from outside and to the inverting terminal, and another input from the ramp generator, that is the non-inverting, that is to the non-inverting terminal. Now if the VA is greater than VR, the comparator gives the high output, that is logic 1. If VA is less than VR, the comparator output gives low, that is the logic 0. If the output of the comparator is connected to the AND gate, and the another input of the AND gate is from the clock pulse, the output of the AND gate is clock, it means the clock is low. If the output of the clock pulse is high, the applied output is the 1. ఏం లేదు, ఇక్కడ ఎప్పుడైతే మనకు AND గేట్ యొక్క అవుట్పుట్ అనేది 0 వస్తుందో అప్పుడు క్లాక్ పల్స్ అనేది లో ఉంటుందో అప్పుడు అవుట్పుట్ అనేది 0 వస్తుంది. లో ఉన్నప్పుడు అవుట్పుట్ అనేది 0 వస్తుంది. మనకి అవుట్పుట్ అనేది హై ఉన్నప్పుడు 1 అనేది అవుట్పుట్ అనేది వస్తుంది. నెక్స్ట్ the output of the AND gate is connected to the binary counter. It means the counter counts the clock pulses and stores. Now here for the storing purpose we are connecting latches in series with the counter. The output from the counter is given to the latches, then the latches circuit as well as to the display unit. The output from this total completed circuit gives the output in the display unit. Here decoder will convert the n inputs to the 2 power n outputs, but we have two different input and output ports, that latches and to the display unit and to the display end. For the purpose of matching we need to use two to the decoder. So the clock pulse is 0 is applied to the counter, it stops counting. If the clock pulse is applied to the counter high, that counts and stores the clock pulses in the latches. The stored value in counter is displayed in the displaying unit. So this latches and to the decoder. For the controlling this total process we have a control logic. It controls the total ramp generator, counter, latches. The output of the comparator is connected to this control logic, or it is also called as a control unit. It will reset the counter as well as the latches. Control unit also controls the ramp generator. Now then the main purpose of the control unit is the counter It unit is resets and counters, counter and latches stores the step by step data. So we have to erase the previous data stored in it. So the main purpose is to reset these values which is stored in the previous. Now in order to erase the reset previous data, we are using the control unit or control logic. Total process, when the comparator gives the 0 signal, then we know that VA is the less than VR. So the RAM generator starts generating the signals that after the completion of this total process, it will display in the display unit. For example, if we take that VA is equal to wait 1 minute. For example, we take VA is equal to 5 volts. Next VR is at starting point. Now VR is equal to 0 because it is in starting point. At initial condition, the data of the binary which is produced by the binary counter is 0 0 0 0 0 0 0 0. This is the output of the binary counter at initial condition. Now when VA is equal to 5 volts and VR is equal to 0, comparator, the output from the comparator is 1. Now 5 less than 0. In this condition, the counter starts again counting. So VA less than VR. The output now the output of the counter is 0 0 0 0 0 0 0 1. 0 0 0 0 0 0 1. So now the counter, 1 minute. Now here the counter counts continuously again. The counter count continuously because the same previous thing is repeated here continuously again. VA is equal to 5 volts. And VR is equal to 1 volts. Again VA is less than VR. So comparator output is incremented by again 1. Again it is incremented by 1. So the output of the binary counter, the output stored in a binary counter is 0 0 0 0 0 0 1 0. Now again the same process repeated. Next again clock counts. VA is equal to 5 volts, VR is equal to 2 volts. Next to 5 less than 2, 5 less than 3, 5 less than 4. The process continues for several steps. Here comparator generates again output by 1. So again one number of output is increased in the binary counter. So here 5 less than 6. Then here the comparator gives output is 0. The output of the comparator gives is 0. At this condition, at 5 less than 6 condition, The clock value the clock value will not be produced. The clock will not be produced. So the previous value which is produced in the comparator is stored in it. Now we will learn some of the drawbacks of the RAM generator. First one is the resolution is very less. Resolution is very less. When again second one is the temperature effect is more on the RAM generator. Temperature effect is more on RAM generator. So by this effect, this converter will not produce exact values due to the temperature effect. Due to the temperature effect, this converter not able to produce the exact values. So the ramp voltage are so in that ramp voltage we get some errors. So these are the some of the drawbacks of the RAM generator. This is a total explanation about the RAM type analog to digital converter. Thank you.